Here we go. So we're going to play around with some more volume by collecting a bunch of slices. This time we're going to get the slices by rotating an object. So let's take a look here. We've got y equals x squared. So let's get a graph of that. X to 1, y equals 0, about the x-axis, all right? So y equals 0 is the x-axis. And then if we plug in 1 to our function here, we're going to get the point 1, 8. So we get the point 0, 0 down here. And let's say 1 is over there. And let's put 8 up here. So they don't have the same scale, but that's OK. We got a point up there. So we got this parabola looking thing. Whoa, that didn't go so good there. Let's try again. Sweep down. So here's my parabola there. X equals 1 would be this line here. And then y equals 0 is the axis here. So my area I'm rotating is this chunk here. And I want to rotate that sucker about the x-axis. So when I do that, then I'm going to get a shape that looks kind of like this. Let's draw it off to the side to the best of my ability. Let's see, we use blue. It'll be flat on that side. And then it will be parabolic, having a peak maybe right here. So something like that. We'll have this 3D shape. And this side here will be circular. So trying to draw, it didn't come out so good. Let's try that again. All right, that would be a circular bottom here. Something like that. So this kind of dish type thing. All right. Now, when I do that, I'm going to have a slice. Right? So imagine a circular slice of this. Right? It's going to be a circle. So there's a bunch of circular slices. And I need to know the volume of those slices. So they have this little thickness. That little thickness is going to be a dx, and this will be the radius of that circular slice. So I'm generating these disks that have a little bit of thickness to them. That is my dx for the thickness. And then the radius here, well, the radius is just the y value from y equals 8x squared. So then my cross section here is going to be pi r squared because it's a circle. And then it's got a little thickness, that's dx. And r here is my 8x squared. So that's going to give me pi parentheses squared. My radius is 8x squared. So that is the volume of one of these slices given an x value between 0 and 1 and whatever little tiny thickness dx is there. And we just want to add all those up. So our volume then is the integral as x goes from 0 to 1 of all of these disks that are going to make this three-dimensional shape. And that's going to be pi parentheses 8x squared squared. So pi r squared. R is that y value right there, dx. Cleaning this up a little bit, we can pull out the pi, we can pull out the 8 squared, so those are constants, and then we have x going from 0 to 1, x squared squared would be x to the 4th dx. So then my antiderivative here will be pi times 8 squared times x to the 5th over 5 from 0 to 1 and evaluating that. Plugging in the 1, I'm going to get pi times 8 squared times 1 to the 5th, which is just 1 over 5, minus, when I plug in 0, is 0, so that's kind of cool. So then my final answer here is, I guess we can write 8 squared as 64 now. 64 pi over 5 is my volume of this three-dimensional shape. So like we were doing before, we got to come up with a cross-sectional formula. This time that comes by rotating some two-dimensional object to get a three-dimensional object. And we got to pay attention to which axis we rotate about to determine the radius that we need. Good work.